Hi guys, welcome to this video. So let's talk. This is actually conceptually very interesting. That is sine theta equal to 1 over 2 or versus theta is equal to sine inverse 1 over 2. Are they one and the same thing? So the short answer is no, they are not the same thing. And why are they not same? Let's talk. For that we need to talk about both the functions separately. So let's talk about sine theta is equal to 1 over 2. So I think if we analyze this graphically, it's going to make more sense to us. So let me just actually try to understand this using the graph that what sine theta is equal to 1 over 2 actually represents. So can I consider this as two functions? One of the function is y is equal to sine theta and another function is y is equal to 1 over 2. So if I'm equating both, basically I'm trying to find their points of intersection, right? So let's try to find their points of intersection graphically. So I'm going to make a graph over here of sine theta, and we know that sine theta is a periodic function. So let me just draw a rough sketch of this particular graph. So let's say this is the one cycle, perhaps this is another cycle, and so on, and this is one cycle towards the left, and so on. This will continue till negative infinity and this will continue till positive infinity. We know that the maximum value of sine is 1. Here we have pi over 2, here we have pi, here we have 3 pi over 2, 3 pi over 2, and here we have 2 pi. All right, and of course the minimum value is negative 1. Now, where is y is equal to 1 over 2? We know from the linear equations that y is equal to something, whatever that is actually a horizontal line, right? And how is that horizontal line going to look like? So this horizontal line is going to look something like this, which passes through 1 over 2. So let's say this point is 1 over 2, this blue dot is 1 over 2. So the y is equal to 1 over 2 is going to look something like this, right? So I'm going to mark this as y is equal to 1 over 2. So now you notice that for sine theta is equal to 1 over 2, if you want the solutions are going to be, let me just highlight these points. So this is one of the point, this is another point, this is another point, another point, another point, another point, and so on. So you can see there are infinite solutions to this particular equation. And how to write those solutions? We know that we have to just find all the possible coordinates in the first time period, and this is the first time period, right? And we can clearly see that there are two possible solutions in the first coordinate. In the first cycle time period. Or so what is this first point? So a little bit of playing with the numbers over here. We know that sine 30 degrees 1 over 2. So one of the angle is sine 30 degree, and since there is a symmetry, so if this is 30 degree, from 0 to 30 degree, I'm going 30 degree forward. So likewise I can come 30 degree backward from 180 to get another value. So 180 minus 30 is actually 150 degree. Right, and this is where I use the concept of the time period, because these are some specific solutions only in the first period, but the general solution is going to look like 30 degree plus 360k and 150 degree plus 360k, where k is an element of integer. Right, k is an element of integer over here. So I very clearly write that since k is an integer, whatever values of k we put in, we can keep getting the various numbers of n. Like if we add 360 to it, we'll get this point. If we subtract 360 to it, we can get another symmetric point, which is over here, and so on. So we'll get all the solutions of this particular equation like that. Okay. Now let's talk a little bit about what the other function represents. So mind that the other function is an inverse, and inverse functions are not periodic functions, remember. Why is that not periodic? Because see, we went to sine inverse from sine. And remember the property that when can we actually calculate the inverse of a function? When it is 1, 1. So if we want to make this 1, 1, we have to restrict the domain. And because we restrict the domain, when it becomes sine inverse, it is no longer periodic function. So if you remember, the graph of sine inverse is very important for this question. So let's try to make the graph of sine inverse x. This is how it's going to look like, and the graph of sine inverse x looks something of this sort, right? So this is the value where we plug in the number. So this is where we have 1, and this is where we have -1, and its maximum value is pi over 2, and the minimum value is minus pi over 2. So I'm going to write that this is the graph of y is equal to sine inverse theta, where sine inverse theta, or sorry, it's not sine inverse theta. Basically, we have to write this as theta is equal to sine inverse x. This is theta and this is x. All right. Now we can clearly see again, what do we have to solve for? We have to solve for y is equal to, let's just go back again and see what the other equation was. It was theta is equal to sine inverse 1 over 2. All right, sine inverse 1 over 2. So when is theta equal to sine inverse 1 over 2? Obviously, when x is equal to 1 over 2, right? And when is x equal to 1 over 2? Clearly at this particular point. At this point, this is where x is 1 over 2, and if we want the value of theta at sine inverse 1 over 2, basically we are looking for this particular point, right? This particular point. And clearly we can see that this is only and only one solution, only one solution. There are not infinite solution. It only has this one solution for this inverse trigonometric function, right? And that is a very big difference between the trigonometric function and when the same thing is manipulated and is being written in the inverse trigonometric form. So the inverse trigonometry actually converts that everything into just finite number of solution, and we know that this is a positive number, and we know that when it's sine 1 over 2 at 30 degree, of course, so we'll say that the solution from here is 30 degree only, in contrast to what the solution we get on the other, on the the first part, which was written in trigonometric form. So I hope you understand the difference between manipulating a function. Always remember that whenever we manipulate a function, right, we have to take care of the new properties that the function is actually bringing in. We cannot have some other properties of the function for after the manipulation. So the property changes, and that's how we have to deal with those functions accordingly. If you have any questions, please post it down in the comment section. Thank you very much.